It's okay, I'm gonna record and I'm gonna share my screen. I'm going back to sharing the screen. And I want to explain something. So when you go into your course now, as you're able, you should be able to see on the left-hand side, do you see this label by chance where it says My Lab Mastering? Yes? Okay.
Yeah.
So when you click on that shelf, it should take you to your class. And all you need to do is hit My Lab Mastering. When you hit that, do you see your assignments? You should be able to at least see week 1. Because I did open week 1, and that's the only one I've opened right now, as of now, based on her request. So if I go to assignment manager, I'm able to see week 1. And this did not take. So I had edited this for you. And so no, I don't want to do anything with this. Do you see week 1 by chance or no?
I see it's asking me for an access code.
It's asking you for an access code.
Yep.
Yeah, mine asked you for an access code as well. Usually they email it to you, but I didn't get an email yet.
Okay, so if I go to My Pearson, hang on, maybe you can see it in My Pearson. And I have to resync this. This is why you're not seeing this, but I'll show you this for now. Bear with me for a second. Okay, so the access code that you need for this would have to be, let me ask you a question. Could you put try Borrazzo, BORRAZZO18363? Can you try that? And see if that works for you? I'll write it on the screen if it helps you to see it on the screen. So if you try BORRAZZO and it's 18363, you should be able to access my class or the class that we're in. No, helping.
For me, those the name and the numbers only filled up 2 out of 6 boxes, so it won't be big enough of an access code to work.
So you're saying the Borrazzo 18363 doesn't work?
Not where I put it in.
Okay, let me text her and see why that is. I do have a reference. How many numbers are you looking for, Andrew?
So there's 6 boxes. Looks like 5 for each box.
If you guys go to the inclusive access red shelf, then go, and that should pull up like your red shelf area, and click on my lab math with Pearson eText access card. That's where you're gonna find your number.
Okay, Andrew, 1 second. If I have you, can you share your screen? I'm going to give you access. Go ahead and see if you can share your screen. Hi, Jan. I was just looking for you. I'm glad you're here. Awesome. So the link does work for you, so that's good.
Hold up.
Yeah, so if you can share that with us, it's at the bottom of the screen. It'll say share screen.
Yeah.
So they can follow your lead on this.
Let me see. Let me do it now. There it is.
Okay, and I am recording this, by the way, in case you have any issues with this. So hang tight.
You should be able to see this screen, right?
No, right now, yes. Okay, there you
Okay.
go. So-
It's so you go down. So your classes. You go down to here, inclusive access,
Mhm.
your red shelf. It's gonna pop this up, and then you're gonna click on your materials. Then you just copy this code.
Oh, there you go.
Should be able to put it in.
So that's what the code is.
Yep. But yeah, you're good. I'll say because mine also popped up for your class.
Mhm.
It gave me two. Because when I first did it with the went through right here, my lab mastery,
Mhm.
and so now I have two classes of yours. This one and this one you just gave us. They both work though, but this one isn't showing anything. But yeah,
That's strange.
yeah. So
If you click on that one, is it showing the assignments?
yes, this one does show the assignment.
Okay, that's the one you're gonna hang on to, which says Calculus WU Online Live.
Yeah,
That's the one I created with mhm.
yeah. So I just wanted to-
So we're using the Barrazo 183631.
Yep.
All right, very good.
Stop sharing.
Thank you so much for doing that, Andrew. I really appreciate it because I don't see the student view. I only see the teacher view, which is very different.
No problem.
Is Jennifer, everybody who's on the call, Isaiah, are you guys good with on accessing the book now? Is Matthew, Mohammed, Spencer, Joey, and
I'm checking right now. See,
okay, and Chalia? Did I say that right?
It's Shilea. I got it. Thank you.
Chalia, wonderful. Okay,
I got it too. Thank you.
you did. All right, good, awesome,
I got it as well.
good, good, good.
Yeah,
And
it's
Louis,
okay for me as well.
Louis, get back here. Generate.
Yeah, I got it.
You're good, 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 good. All right, awesome. All right, so now that everybody's there, what I'm gonna do is I also want to let you know that I'm first week, you're gonna get a little bit more time. Usually I do 1 week at a time. I'm thinking I'm gonna do Thursday to the following Sunday. So look at your calendar for a minute. You'll see we have class today. Oh, it says August 31st. I don't have your next assignment due until the following Sunday, which I believe is 9/10. Is that correct? Anybody with a
Yes.
calendar? Yeah. So yeah, so I have your first assignment 8:31 to 9:10. And we're gonna follow that kind of pacing where I give you a little bit of time over the next week. So the next week, obviously, we're starting a new session, but I will give you from there the same amount of days and so on. Okay. So I think that's fair. And if you need anything open, we can always open up an assignment and whatnot. Does that make sense? Yeah. So we're gonna stay on par, but even if you fall behind, I understand. Like for example, Jan is traveling for stuff. Akil, you look like are you also yeah.
Yeah, I play at spring sports, but I won't be traveling in the fall.
Okay, so I just figured whoever might have some, some sort of time glitch, I understand. So, all right. So would you like to start the lesson now? Are you feel comfortable with coming in? At least right now we're focusing just on week 1. And I will open everything else so that if you want to work ahead, you can, especially on the homework. There are dates and times for the quiz and the tests, so you should be fine with that as well. And you'll see that plenty of time ahead. Okay. So let me go ahead with you right now, and let's look at the lesson itself. So I'm going to show you my screen, and in my screen, this is the lesson for what we have. Let me see if I can preview it. So access 9, and I'm the professor and I can't see the lesson. Are you kidding me? This is a joke. I think this is a joke of epic proportions. Give me 1 second. So, I'm gonna go to the e-text. And it looks in this section. What did I say we were covering this section? Do you remember? It's on the syllabus. I believe I said we're covering. I'll go back to the syllabus. Bear with me. According to the syllabus, we are looking at this section. Bear with me. It's very slow to populate. I don't know why it's doing this. It's so weird. This is strange. Bear with me. Let's do it through the module at this point. Okay. I think my TA must be looking at what we're doing right now. So in the introduction, we'll start with week 1, basic. We're dealing with, in this case, graphs, solving equations, including quadratics, polynomials, rational expressions, and whatnot. So this is, we're looking basically at reviewing is what it looks like. And let's see. So we're looking at these examples. Have you guys had a moment to look at these videos by chance? Hello?
Yes, I watched them because I
You
needed to
did watch
catch up
them? Okay.
on the stuff.
I watched them.
Okay, good. I strongly urge you to do so. So I'm looking at 1-1. It's basically slope and equations of lines. All the prerequisite information here. We're looking at translating a parabola. Some of the basics. So based on this, it looks like we're just doing the first area, the first type. So yeah, how are you guys on factoring? Completing the square? Good, bad, indifferent?
It's been a while since I had to do it, so
So let's talk about it. Let's talk about it. Okay, so I'm going to go back to my drawing board here. And we're gonna look at basics of factoring. So let's take a look. This is all part of the review of what we're doing. And we're talking about translations and all that as well. So starting with factoring. So as I look at, just for the record, I'm on R6. We're just basically reviewing some details here. And in factoring, I'm looking at factoring 12p minus 18q. So the first thing I'm thinking about is there a common number, multiple here, a GCF, that we can use that is common to both of those?
Well, I think it's 2.
Go higher.
6.
Here's a hint. I know that 2 times 6, for example, that is 12. And I know that this is also 3 times 6. Because of that, I know that 2 is too small. If I kept dividing by 2, I would end up with 6 anyway. So if I take out a 6 here, I end up with 2p minus 3q. Is that clear? Are you good with that or no?
yes, it makes sense to me.
All right, is there anybody who needs another example?
No.
No, you're clear. Okay. More factoring, this would be factoring a trinomial. So we're factoring a trinomial. They're giving us, in this case, a factor where we have y squared plus 8y plus 15. Can you think of a way we can get 8, but get a multiple of 15?
3 and 5.
Yeah, 3 times 5. So we know 3 times 5 is 15, and therefore this has to be a y plus 3. And this has to be a y plus 5. And if you remember, y squared, the result of y times y, inner term product and outer term product, that's how we get 3y and 5y, a total of 8y. And the last term, which is 3 times 5, that's how we get the 15. So remember, these are, as we learn the terms, these are factors. And if we want the solution itself, we have to solve for this in terms of 0. So we would take, for example, y plus 3 and set it to 0. We would take y plus 5 and set that to 0. So we get a solution where y equals -3, or here is another solution where y is -5. Is that clear for everybody? Yes, no?
Yeah.
Want
Yeah,
another
yeah.
example?
Yeah.
Yeah,
Yes, you want another example?
sure.
Let's do another example of just plain old factoring. So in this case, let me make one up. And let's say we have, let's say I have x squared plus 7x plus 12. Can you think of two numbers that multiply?
3 and 4.
3 and 4. And you also know that 3 and 4 as you add them is 7, right? So that's how you always want to ask yourself, what two numbers give us that product, but add up or subtract to give us that number. And so this is how we know that it's x plus 3 and it's x plus 4 in this case. Tell me how you feel about that.
Good.
Good.
Okay, can I move on?
Yeah.
Awesome. All right, so bear with me, I'm texting with the okay, so what about when you have a factor or trinomial like this one? What if I said to you, I have 4x squared, I have positive 8x, actually 8xy, and I have a negative 5y squared. What comes to your mind? Now remember, this is a product.
2 and 2 and 5 and 1.
Okay.
Bro,
So you're gonna go with 2x and 2x. You said 5 and 1. Where am I putting the 5? If
Would
this
it
is
be-
2x times 2x, right? Where do you want the 5?
Would it be the +5 in the first bracket?
Okay, so you want +5 here. And what else do you want? +5y, by the way. And here you want obviously -1y, right?
Mhm.
Now, here's the idea. The reason why this works is because, yes, 2x times 2x, that gives us a 4x squared. 5y times -5y, or -y will give us -5y squared. And then this product, which is 10xy, and outer product, which is -2xy, that lands us at +8xy. Is that clear for everyone?
Yes.
Awesome. Is there anybody who's still stuck on that? Are you okay with that?
Yes.
I assume yes. Do you know what factor by grouping is? Are you comfortable with this as a concept? Would you like to talk about it?
Can you do some examples?
Yeah, I can. So we want to factor by grouping. Let me give you, give me a minute. I gotta pull one up out of my sleeve. Okay, let me give you give me, okay, so what if I said factor 6x squared minus 10x plus 24. You're gonna do factor by grouping. And yeah, so 6x squared. Gonna give you minus. Okay. And this will actually, my apologies, this will be -24.
Would you divide by 2?
You could. That's a thought. You could definitely start by doing that. So if you divide it by 2, you would start with 2 parentheses 3x squared minus 5x minus 12. That would work. continue with that. You can do the AC method if you want. You remember the AC method? Where you have 3 times 12? Well, 3 times 12 is what? 36, right? What are the factors of 36? What are two factors of 36 that could potentially give us a negative 5x?
9 and 4.
Yeah, I'm thinking 9 and 4. Okay, so we split this area here. So this is 2 parentheses 3x squared. We're going to go with a negative 9x, but a positive 4x for the middle. So if you notice, I added x terms to these. So if you complete it, this is what you have. Do you agree? And this is how we stretch that middle term. So all this middle term is now all this. And this is where factor by grouping comes in, because all of this gets split. And now I'm focusing just here, what's common. What's common here? So I'm thinking if I
3x.
take out 3x, yeah, this will become x minus 3. Over here, what's common?
4.
Plus 4. A positive 4, and I have to add x minus 3 in here to finish the factor. So if you notice, and yes, by the way, all of this is still multiplied by 2. If I split this up further, this becomes 2 parentheses of 3x plus 4. That's this first term right here. And the second term is the x minus 3. So that's what that factor by grouping concept looks like. And if you remember, this is always equal to 0. So if I solve for the solutions, I know that one of the solutions is negative 4/3, and the other solution is positive 3. So if that's something that you want to review, we can definitely take some time and just do a review on that as well. So that's the basics of factor by grouping. Do you remember that, or is that something that's foreign to you or new to you at all, or no? I would assume not.
It's vaguely familiar, but it's been over a year since my last math
It's
class.
been a while, right? Yeah, that's why we start with a little bit of a review before we begin diving in.
I have a question slightly off topic, just because I just got my computer and went into the assignments. When I went into my math lab, it said that all the assignments were like past due. Are you gonna change
No.
the dates on
Yeah,
them?
of course, of course.
Okay, I just want to make sure because I can't access
Yeah.
any of the homework because it says
No,
that they're past
we-
due and that like it expired.
Right now, you're working with my lab, what I have, and I am getting that corrected with the department chair of the calculus group, because it
Okay.
was just a Pearson glitch, which we figured out, and now we're taking care of it.
Okay, perfect. Just wanted
Yeah,
to double.
so just hang tight. I'm literally gonna spend tonight to get you guys all set up, so you're set up at least for week 1 and 2, and you should be good to go.
Okay, thank you.
So yeah, it's been a little bit of a headache for me too. So, okay, so going back to the review, so that's factoring polynomials. You want our factor by grouping. I do want to do a little quick recap of special factors, if you don't mind. Do you remember the difference of 2 squares? What that is, by chance?
A plus B minus A plus B bracket A minus B.
Yeah, so that usually they do a minus b or a squared minus b squared. That's usually what I'm used to. And or x squared minus y squared, whatever it is, it's the first term squared minus the second term squared. So that's an example of what that looks like. So for example, this is really x squared minus 3 squared. Do you remember that? Which, if you think about it, this is really a sum difference where you have x minus 3 times x plus 3. And if you notice, the middle terms cancel because you have negative 3x, positive 3x, the middle will cancel. So that is called the difference of two squares. A perfect square, you probably have seen this where you have like x plus y squared, which really means x plus y times x plus y. And as a value, this is always going to be where the x squared plus 2xy plus y squared. Again, I'm just recapping this for you. This is called the perfect square. And you see this with also the negative. So I can have x minus y squared. And that simply becomes x minus y times x minus y. Which, as we finish this is x squared minus 2xy plus y squared. So these are special perfect squares. They're either positive or negative. Do you want to see a factorization of both of those, or this is old news? Keep going. Yes? Can you guys hear me?
The factoring for it, please?
Yeah, sure.
Thank you.
So like if you have something like x plus 3 squared, for example, is that what you're asking? Yes?
Just any example, really, it doesn't matter.
Well, here's an example.
Okay.
If this is the direction you want to go, then this would be basically x plus 3 times x plus 3. And so the result of this is x times x is x squared minus 3x, or sorry, plus 3x again, you get plus 6x plus 9. The last terms, 3 times 3 is 9. Is that easy for you to capture?
Yes.
All right. If I have, say I have x minus 5 squared. All right, so this is simply going to become x squared minus 10x and plus 25. Right? Because if I set it up again, this is x minus 5 times x minus 5, right? X times x, x squared, minus 5x plus minus 5x is negative 10x, and lastly, the product, negative 5 times negative 5, positive 25. Okay, is that cool?
Yeah.
All right, let's look at the cubes. Do you guys remember the cubes? This is also another concept. If I have an x cubed plus a y cubed, when I factor this, we always use x plus y times the x squared minus xy plus the y squared. And that's how you factor a perfect cube or perfect trinomial. So this is factoring. I don't want to say perfect, but these are definitely trinomials. or cubes. So I'm just gonna write this for you here. And just remember this also is or cubes, like cubic functions. There's also the negative of this. So if I have x squared minus y cubed, I'm sorry, x cubed minus y cubed, this, if you notice the pattern, this will be x minus y. And then it starts with x squared plus xy plus y squared. So if I ask you, can you factor? The question would be, can you factor? And we would factor this to be able to find the solutions. Can you factor something like x cubed plus 27?
Yeah, you could write the 27 as 3 cubed.
That's correct. That's what I was waiting for. So this 27, and that's why knowing your cubic functions or cubic values is important. X cubed plus 3 cubed would be how you write this. And if you do that, now follow this pattern. If you go up to the positives, this will become x plus 3. And we would continue this with x squared minus 3x, because it's always opposite sign if you remember. And this is plus 9, because that's always squared. You want to try another one of those just in case? Because it's probably a hot spot for some of you.
I have a
Yes.
question.
Yes.
Oh, you had a question? Somebody said they had a question?
Yeah.
Talk to me.
So, after you get the end result, do we factor that further, or is that the
Yes,
that
you
enough?
do factor it further. Now, this obviously is set to 0, right? So one of the solutions is as x is equal to -3. And this you would have to throw into the quadratic formula because it's one of those strange. Do you know the quadratic formula?
Yeah, is it AX?
So this is the -b plus or minus the square root of the discriminant, which is b squared minus 4ac. And all of this is over 2a. And so just for the record, remember that at this point we have ax squared plus bx plus c in our formula. So in our case, we're paralleling it with 1x squared minus 3x and then plus 9. So the a term in our case is 1. The b term is -3. And the c term is equal to 9. And we literally plug it into the formula. And that's how you find your x values. So these are x-intercepts of some sort. I believe with this example that I just gave you, this one here, you end up with negative or imaginary numbers. So you want to work it out and see what you get? Or do you want me to just do another example altogether and just keep going? What do you prefer?
I guess another example.
Okay, so let's do x cubed minus 64. Factor. Go ahead and factor that.
Is that 4 cubed?
That's 4 cubed. So this is really written as x cubed minus 4 cubed. So now we continue factoring that trinomial to get x minus 4. And this becomes x squared plus, it's always the plus the 4x, and then plus obviously 16. Once again, I promise you, if you do the quadratic formula, you're going to get imaginary number. All right, talk to me and tell me where you are. Are you good there, or are you feeling lost?
I'm understanding
I'm-
this stuff.
Good.
Yeah, I'm good.
Good.
Is there anybody who's dying on me or need another example, whatever the situation is?
No,
No, keep going. Okay,
Yeah.
so I want to talk to you now, if you don't mind, just factoring polynomials all around. And I'm gonna throw just some practice ones at you, some of these that are not the norm. And let's see how you feel. If you feel good, I'll keep going to rational expressions. All right, so let's start with get ready for the madness to start. So I'm gonna give you 13 p to the 4th power q to the 2nd power minus 39 p to the 3rd power q plus 26 p to the 2nd power q to the 2nd power. So basically you're going to factor out the GCF, the greatest common factor, and tell me what you get.
Wouldn't the greatest common factor be 13?
Does 13 go into 13? Does 13 go into 39? And does 13 go into 26? So I'm happy with that because 13 definitely works. So you get 13. And now as far as the variables, what goes next?
P square.
Just a p square? What about the q?
Yeah, Q as well. P
Yeah.
square Q.
So I'm thinking p square q for this one, right? So this will be, I'm sorry for the mess. So this will be p squared, the smallest power, and q is the only high power. So p squared q. Okay, and now we factor. So what am I missing in this term? What am I missing?
P square Q.
Just p squared q again. What am I missing here?
Just the P.
Yeah, so this is, what about the number?
3.
Minus 3, right? So minus 3 and then p, and then what am I missing here?
2.
So plus 2 and
2Q.
just the q. So you remember that when you multiply exponents or like bases, you're adding their exponents, right? Remember that.
Yeah.
Would you like another one of those or?
Yeah.
Yes. Okay. Let's do another one just in case. Again, factor out the GCF. So I'm going to give you 60 m to the 4th minus 120 m to the 3rd n plus 50 m squared n squared. What's common?
10.
What m?
I said 10.
N? N is only present here.
Not 10.
here.
10, the
Yes.
number 10.
Oh, 10. I'm sorry. So we're taking out 10. Okay. And what about the letter? What variable?
No, I think we should take 12. No, yeah, 12. No, I think
So
it's
go
10.
to
My
50?
fault. No, it's 10, not 12.
Yeah, it was 10. And then as far as the variable, what am I taking out?
M squared.
Yeah, that's the only thing you can take out because n isn't present in everything. N is only present in these two, the 120 and the 50. So if I take out m squared, now I can finish. So I'm missing a 6 m squared minus, what am I missing here?
Minus 12 mn
12 mn, right? And what am I missing here?
plus
A
5n squared.
a 5n squared. So yeah, you always want to finish it as best you can. Can I factor that is my question. Is it possible I could factor all of this? Think about it. Maybe you can, maybe you can't. I know 5 is definitely a rational number. Six could potentially be 6 and 1. Or 3 and 2, your choice. Or is that good? Is that as far as we go? I think that's as far as we go. Okay, what about expressions, rational expressions? How do you feel about rational expressions? Do you know what they are? Do you know how to deal with them?
I know I've heard it. I think I covered this before, but I don't remember exactly.
Okay, so let me just throw a few at you, and then we'll go from there. What if I have something like 5x squared over 55x? Can you reduce that? Does 5 go into 55?
11.
Yeah. So this is really at least 1 over 11 as far as the coefficients. What about the x's? You have an x squared and an x to the first. What do you think this answer is up here?
X by 11.
Just x. So it'll be x over 11 is the final answer. If you have trouble seeing why that is, remember that if I am looking at this in terms of 5 times x times x, this is over 5 times 11 times x. So the 5s will cancel, the x's cancel. And that's how you end up with x over 11. Make sense?
Yeah.
You okay with that? All right.
Yes.
Let me give you a little bit more challenging one. Let's go with, what if I give you 36 y squared plus 72y, and this is over 9y. Do you know how to factor that?
Nine goes into each of those numbers.
Okay, very good. So you're dividing in here. You can actually rewrite this if you wanted to really be clear in your notes. So this is really 36y squared over 9y. This is really 72y over 9y. So you can think of it that way. So 9 goes into 36 4 times. And then keep going. We know that y goes into y squared y times. So in essence, we end up with
+8.
I was gonna say 9 goes into 72 8 times. So I wouldn't use this notation, which is I jumped the gun on that. Let's just use straight up division. So this becomes again the 4y, and this becomes plus 8, because technically 9 goes into 72 and the y's will just cancel. If you factor out the 4, now you have y plus 2 as your final answer, and that's factored all the way down. Was that all right for you? You feel confident with that?
But you said you would get y plus 2. I got 4y plus 8 over y.
There's no y. The y is, okay, so go back here. Remember, this 9 goes into 36 4 times, and y squared divided by y is just y itself on the top. 9 goes into 72 8 times, the y's cancel. If I factor out the 4 now, 4 goes into 4y, y times, plus 4 goes into 8 twice.
Okay. Thank you, miss.
If you distribute, look at the logic. If you distribute 4 times y and 4 times 2, you're back to this.
Okay.
Does that make sense?
Yes.
All right, let's
So
look
does
at
it have is the only solution -2?
the actual solution for this would be y is equal to -2. Yes, because
Is
the
that
number
it?
doesn't carry a value other than itself. Make sense? Okay, let me give you another doozy. This is a really this is a good question. So let me give you, I like this one. Let's do this one. It's 3x squared plus 3x minus 6. All of this is over x squared minus 4. So go ahead and try that one. So how many of you by chance are already thinking, let me take out the 3. So this becomes x squared plus x minus 6. And all of this is over a perfect square, x minus 2 times x plus 2.
Wouldn't it be over 2 if you take out, x minus 2, if you take out the 3 in the top part?
So, oh yes, you're talking about here, my bad, yes.
Mhm.
So, and yes, now can we factor that top part further?
Do you mean, can you cross out one of the factorial on the bottom?
Can this be factored further?
Is it a perfect square or is it like
It's not a, no, it's not a perfect square.
one minus one?
So let's just do the math. If I'm looking at this, x times x is x squared. We agree? This is a +2, so this has to be a +2 minus 1. Because I
yeah.
need a -2. Do we agree? And this is x minus 2 times x plus 2.
And then with the x plus 2, they cross out. They cancel out.
Yes, this cancels, correct? So your final answer here will be 3 parentheses x minus 1 over x minus 2. All right, would you like to try another one of those? Or move on?
We can try another one of those if it's up to me, but what was this called again?
This right here is rational expression, and we're trying to express it in its lowest term. So we're trying to reduce it, basically.
Can we do one more, please?
We can do as many as you
Thank
like.
you.
So, let's do this one. I'm going to give you an m squared minus 4m plus 4. All of this divided by m squared plus m minus 6. We're just doing this to rehearse some old stuff that is important in calculus, because unfortunately some of the stuff is key. And then following this, I have other stuff I want to cover. So what do you think that final answer is going to look like? I'm thinking this is a perfect square. I'm thinking this has to be m times m. So if you notice my logic, m times m, and then this is a negative and that's a positive. So they both have to be negative, right? Because a negative times a negative is a positive. And this is negative, so it's telling me that has to be negative. And only 2, so 2 times 2 will give me that same answer, because negative 2m, negative 2m is negative 4m. Make sense?
Yes.
I'm looking at this one, and I'm looking at a negative here, which means that this has to be a plus minus. So this has to be m times m, which is going to give me m squared. And again, a plus and a minus, because a plus times a minus is this minus here. And that means that if I'm looking at two factors that are 1 unit apart, that's what I'm looking at. So who cancels?
M minus 2.
Yeah, they cancel. Your final answer is m minus 2 over m plus 3. Okay. Are you okay with this so far? Is it helping bring back some brain juice, brain power?
Certainly is.
Awesome. Awesome. All right, so let me see. All right, so in our concepts for today, the gist of what we're covering is pages 63 to 114. So that is quadratic functions, translations, reflections. So I'm kind of glad we started here because of the fact that I want to make sure that you are comfortable with the graphs or with the functions as I do the graphs. So when we talk about going back to the notes, if we talk about the quadratic function, which I did mention earlier, remember that this is in the form where some function is equal to ax squared plus the bx term plus the c term. What I want to mention to you is a couple of things. There's this item called the axis of symmetry. And it's simply the formula, which is negative b over 2a, and that equals the x term. So when I look at a parabola, I don't care where the parabola is or what it looks like. There's a notion that there is some line right in the middle, and it's splitting it exactly in half. So this is like a perfect split in half. Whatever this point is, this point we refer to as the vertex. Okay, and I'm going to also talk to you about that. If you recall the quadratic formula where we did negative b plus or minus, and I did the square root of b squared minus 4ac over 2a. And I mentioned to you that this discriminant, which is b squared minus 4ac, this guy here, so it sounds discriminant. That tells us how many solutions. And let me talk to you about that real quick because this is very easy to remember. Just using this, which sometimes we denote it as a triangle. So you'll hear me use the little triangle, and I say the discriminant, and I'll draw a triangle, which I'm meaning 4b squared minus 4ac has 3 possible outcomes. If that discriminant is equal to 0, then I know that there is only one solution. So I'm looking at some parabola. Here's the x-axis. It's sitting, let's say hypothetically, the parabola is sitting with the vertex at 3, 0, and it's doing this behavior. That's a one solution. This is an x minus 3 squared, basically. So if I were to graph this for you, by the way, which I'm going to do, let me do that so I can slow down for a minute. So we could talk about this and see a picture, because I don't know about you, I like pictures. It helps me to see the big picture. So let me get out of here for a minute. And I am going to go to this, which, by the way, I ask you to write this down. It's called Desmos. If you look up there, it's the graphing calculator. I want you to use that. It's free. I love free. Free is a good thing. So we know that we talked about this, by the way. We said x minus 3 squared, which we know is x squared. In this case, minus 6x. And then, oops. X squared So x minus 3 squared, so that's minus 6x and then plus 9. Looks like this. This is what I'm drawing for you. You notice you have one solution. That's the 1x solution that you get when you graph this type of equation. So you'll get one solution if x is equal to 0 when you do the discriminant. So let's go back to the example. Remember, this is recorded in case I'm going too quick. Just let me know. If you go back to this example, remember how I said x squared minus 6x plus 9. So I need b squared minus 4ac. So b squared is, in this case, negative 6. Your a term, we know that's 1. Your c term, we know that's equal to 9. So if I'm using b squared minus 4ac, then negative 6 squared minus 4 times 1 times 9. This discriminant gives me 36 minus 36. What's the solution? 0. And that's how you know you only have one solution. So this is condition number 1 for the discriminant. Condition 2. In condition 2, if the discriminant is less than 0, then we have imaginary solutions. Okay. So in that case, when we do the b squared minus 4ac, we're going to end up with some parabola that is not ever on the x-axis. So it's like up here, for example, or here, or whatever it is, it's up here or down here, whatever it is, it will never cross that x-axis. In the third condition, if the discriminant is greater than 0, it's just positive, is basically what it means, then we have two solutions of some type. Two solutions, typically two real solutions. So let me give you an example. So if I had a factor of, say, x plus 2, let's say I have x plus 2 times x minus 5 as an example. As a trinomial, this would be x squared minus 3x minus 10, would it not? So in this case, my a term, x is equal to 1. My, excuse me, my a term is equal to 1. My b term is equal to negative 3. And my c term is equal to negative 10. Okay, if that is true, then b squared, negative 3 squared, minus 4 times 1 times negative 10, that gives me 9. 9 plus 40, that gives me a lovely number, is 49. That works. So that's going to give you plus or minus 7 as a factorial. If I throw this in the quadratic itself, look at what's going to happen. And by the way, I already know what my solutions are going to be. This is going to cross x equal to negative 2 and x equal to positive 5. Okay, so if I go to Desmos, I can prove it. So I have, let me write this down somewhere so I don't forget what I'm doing. Okay, so I have I'm going to graph x squared minus 3x minus 10. And I want you to see the big picture. If I do this on Desmos, you'll notice this is going to cross the x-axis at negative 2 and positive 5. So watch. So I have x squared minus 3x minus 10 again. What do you notice? Boom and boom. See? Is that connecting for you?
Yes.
Yeah, it makes sense.
All right. So that's how the discriminant plays a role in your helping you kind of like understand where your diagram is going to sit. All right, good. All right. So a shift. What is a shift when it comes to, we're going to talk about the reflections as well. So, let's see here. So, what I want you to also keep this in mind. Let me give you an example of what I'm referring to. If I just simply graph a basic parabola, so I'm going to call this some f of x, and that f of x is equal to some positive x raised to the second power. So that's just a basic, the parent graph of the quadratic. That's all that is. And if I were to say to you, I have shifts. So if I said to you, I have a vertical shift, I want to show you a vertical shift right away. So do you notice that x squared is by itself, right? And next to it, I'm going to put a 3, for example. -3 at that point. What do you notice happened to that parabola?
The y-intercept goes down by 3.
Right, because the shift is this right there that's highlighted. If I change the shift, let's change it to a positive. So let's go +2. What do you notice about that vertex? It went up 2, right? So when it comes to the shift of the parabola, it's true to itself. So if it's +2, it's going to go up 2. If it's -2, that is going to go down 2. Guaranteed. Now, those are vertical shifts. So please understand that. So when it comes to the shift, we have, in this case, a vertical shift. Remember that that always is like x squared, for example, as your parabola. So that's x squared. And let's say we have a +3, for example. We know that it goes up 3 units. And that's the verbiage we use. We can have a vertical shift that goes down. So say I have x -2 as an example. So we know that the shift goes down, in this case, 2 units. Oh my gosh, sorry. 2 units. All right, so those are the vertical shifts. We also have horizontal shifts. So with the horizontal shift, what I want you to remember is you're looking at the function itself. So like instead of x squared, this is like an x -2 squared, as an example. Or it looks like an x plus, let's make it x +3 squared, as an example. What I want you to do here, and if you please listen to me, I guarantee you they will never have an issue with this. In a horizontal shift, you see how that says plus? It also means left. So you're going to move to the left that many times. This will always be a right shift. And watch what I mean. So for example, let me get back out of here. I'm going to go back to decimals. I'm going to get rid of the vertical. And now I'm going to write this as, let's do parentheses. And I think I said x -3. and I close the parentheses, do you see where it is? Here's the original. I'm going to put the original so you see it side by side. So in the original, I'm asking you to look at this as x squared in the blue. What happens when it's -3? Which way did it go? It went towards what side? Left or right? The right. Okay, look, I'm going to do the third shift here. So if I have f of x, and I say to you, this is going to be x plus 3, and let's go ahead and square that one. What happened there? Which way did it move?
To the left.
To the left. So I want you to remember this model to help you with the shift. Just remember also this acronym, which is not necessarily the most professional thought process, but it is in parentheses. Anything in parentheses is a hypocrite. And there's a reason why I say that. You would think x minus 3 would take you from the middle blue to the green, don't you, mentally? I'm thinking that, but no, it does the opposite. It goes to the red. It goes to the right. If you look at the green one, it's going +3. I'm thinking from 0, I'm going towards the red. No, you're doing the opposite. You're going towards the green. So it's like a hypocrite. Because when you solve for it, you're always solving for the opposite sign anyway, aren't you? If I have x minus 3 equal to 0, isn't x equal to +3? So that's sort of the thought process, if that helps. Is that clear? Is that helping you?
Feel confident already.
Good.
It's definitely helping.
Good. Good. All right. Let me go back to my notes. And I think the other thing they talk about is the vertex form. All right, so let me talk to you about that. Bear with me. Okay. Do any of you have a class right after this, or you're good?
I'm good.
Is there anybody who has to leave at 7:30?
I do. I have a class after this.
That's what I wanted to know. All right.
How much longer is this class gonna be? Because I have somewhere I have to be at 7:45.
We go through 7:30 and we stop.
Okay, great.
Yeah. All right. Real quick, I just want to mention another type of parabola formula. It's called vertex form. And this is where you have y equals some a value, and obviously x minus h, and that is squared. So that's a horizontal shift, and then plus k. Just remember k is always true to itself. The h is not. And this is where we start getting the concept of completing the square. Okay. So in completing the square, let me talk you through an example of how we would do that. So they're asking us to graph and also to finish the equation, and they're giving us 3x squared plus 2x minus 1, and that equals 0. Okay, so and when they get an equation like this, I want to walk you through this as easily as possible to complete the square. That's the key. So in the key of completing the square, we have 3x squared plus 2x plus some missing number. And this is going to equal +1. So we're going to add the 1 to both sides, and we're going to complete it by getting a c value here and a c value here. The c value. Okay, remember what I mean by that. we're saying that this is ax squared plus bx plus c, and that is equal to 0. This c value is equal to b divided by 2 squared. So it's a formula. Okay, my b term, if you look carefully, is right here. So that means that this is really the b term, or the c term for this would be 2 divided by 2 squared, which is basically a +1 and a +1 here. So when we complete a square, this can eventually collapse. And so what we want to do is, if we consider this, this is really 3 parentheses x squared plus 2 over 3x plus 1/9. And we get that from this +1 and this 3 times 1/9. Because remember, we got to multiply by 3 times, and this becomes 1/9 based on the c term value. If that is the case, then we get 3 parentheses x plus 1/3. This is squared, and this is equal to, or actually minus, we could say this is equal to 4/9 or 4/3. If we take the square root of it, it'll be 4/3. So we can talk about this a little bit more as we go through, but see how we now just wrote this in vertex form. Okay, let me do one more thing to the screen real quick, because there's something going on here. This is, it's stopping, I don't know why. Okay. So let me switch screens. I think that's what it is. I'm gonna add a page, and this should stop that from happening. Okay, so we're back to square one here. So the idea of the completing the square is just that. We're transforming it so that it is in vertex form. And so if this is something that we want to revisit or maybe redo, that's fine. I'm just running out of time, and there's so much more I have to cover. So let's do this example, where if I have f of x, and this is equal to negative 4x to the second minus 8x plus 5, let's find the vertex. Let's find a couple of points if there are any intercepts. So at this point, what I would do is we're going to start with a is equal to -4. B is equal to -8. And our C term is equal to 5. Because this is negative, we know that the parabola is going to open down. I didn't mention that. The A value, if it's positive, you have a parabola that's going to open up. If the A term, like it is here, is negative, it opens down. And here, this opens up. I'm sure you remember that from pre-cal. The y-intercept we can find really, really easy, by the way. In the y-intercept, remember that x is equal to 0. If that is the case, x is 0, then the intercept in this case has to be 0, 5. That's given to you. That's easy. If we get rid of the negative, we can actually play with this factor. So let's use negative 4x squared minus 8x plus 5, and this is equal to 0. And let's multiply everything by negative 1, and that changes our perspective to be 4x squared, sorry, plus 8x plus 5. And you can factor using any method that makes you happy. So you can use the AC method, which I would recommend. I'm looking at this, I'm thinking that this is to be a 2x. I think we did this one already as well when we did the practice. 2x times 2x, that gives us 4x squared. If this is minus 1 and this is plus 5, this will definitely give us the 8x in the middle, I think.
Wait, wouldn't the 5 be negative because it's negative 1 times 5?
Oh, yes, it would. My bad. Yes, it would. That makes sense now because I was actually looking at it going, that doesn't make sense right now. All right, so our solutions. This would end up being plus 5. This makes sense now. You would have 2x minus 1 times 2x plus 5. That would work. Because this gives us 4x squared, yes? This gives us negative 5. And if you do inner outer, you do get positive 10x. So our solutions are positive, so x equals positive 1/2. And x also can equal negative 5 over 2. And if you go to Desmos, let's go to Desmos and graph this puppy. So we're going to graph 4x squared plus 8x minus 5. So I'm going to go back to Desmos. Okay, so one more time, we're going to do 4x raised to the second plus 8x minus 5. What do you notice here and here? Those values do work, right? You get x is equal to positive 1/2, and you get x is equal to negative 5 over 2. And if we graph this even better with the negative, I'm going to go back to the original, negative, and this being positive. What do you notice here? What do you notice about that?
It flips it upside down.
Yes, correct. And that was the original function. This is correct. And here's your y-intercept, by the way. So you can find the intercept quickly. You can also determine the x values by solving. And the vertex, which I didn't discuss with you. So let's talk about the vertex. In the vertex, if you do negative b over 2a, in our case, we would have minus 8 divided by 2 times negative 4. And this will end up giving you negative 1. Because this becomes positive 8 over negative 8. And so that's where you get the negative 1. If you take this same number and throw it back into the equation, then you have negative 4 times negative 1 squared minus 8 times negative 1 plus 5. So if we do the math here, this is negative 4 times 1, which is negative 4, plus 9, plus 5. We should get 9 for a total answer. So you get, what is this, 14? And if you go back to Desmos, you can see the value here. Boom. That's your axis. All right. Oh, I need to talk to you about. So there is a discussion on profit, which at this point I want to eventually talk to you about. So what I'm gonna do is for this particular class and just for this particular session, I'm not gonna rush. I don't want to rush. I'm gonna stop early here on the page that I'm at, which is getting into the word problems. And what I want to do is I'm only going to hold your homework up to that section. So I'm going to cut back your numbers. And what I'll do is next week, we're going to start here at this section and finish the next section together. Okay? No rushing. Everybody will just focus on some review lessons. We'll focus on the quadratic formula, axis of symmetry, the zeros, finding hyperbolas. Where am I? Finding horizontal shifts, vertical shifts. I will talk to you completing the square, and then we'll call it a day at that point. So I'm going to set this up for you. And just bear with me, give me tonight. Tomorrow you check it. If tomorrow you can't access it, you text message me like crazy people. Okay? I think you'll be fine otherwise. So just the homework. I'm just gonna give you a few questions. And again, you're getting into the new mix of things. And then I'm starting with some the next chapter and so on. Okay?
Okay.
I want you to feel confident, comfortable, and relaxed. And you can always approach me, talk to me, ask me a question. I don't want you to feel overwhelmed, or for that matter, I want you to feel that you're getting what you need. Thumbs up?
Thumbs up.
All right. I will see you next Thursday then. And if you have a question, you have my cell phone, 754-234-0246. And do not be writing that number on bathrooms. It's a joke. It's a joke. 754-234-0246. All right. I'll see you next week.
Thank you. Bye.
Thank you.
Thank you. Bye.
Thank you.
Thank
Good
you.
night.
Goodbye.
Dr.